No questions from vectors. And our next chapter is differentiation. Okay, let's start with differentiation. We have few things to cover, and these are as follows. Derivatives, dy by dx. Use derivative to solve problems involving gradients, tangents and normals. Derivative is basically the rate or the gradient with respect to a given quantity. Second order or second derivative of a simple function, which would give you the nature of the function. Find stationary points, that means the turning point functions of functions, and determine their nature. So you will be finding the turning points and telling whether they are maximum or minimum. Sketch the gradient function of a given function and model real life solutions, and we'll see what cases we face. So first topic, gradients of the curve. If you are given with any equation, for example, we have y is equals to 2x square. This is a basic curve, simple curve. Y is equals to 2x square. So we ask that find the gradient when x is equals to 3. So at x is equals to 3, you can draw the line and find the gradient for this point. This is one way. The other is go through the derivative dy by dx. How do you do? Y is equals to anything raised to power n. So dy by dx is, we bring the power down, multiply with it and decrease 1 from the power. Do you remember? You've also covered this in O levels. So this is 4x. That is your derivative. You multiply the power with the constant and reduce 1 from the power. Now 4x is the derivative. The question demanded the gradient at point 3. So 4 into, substitute the value of x, this is 12. So 12 is the gradient when x is equals to 3. For example, they ask you what is the gradient when x is equals to 4. So x4 would be at the next value. Dy by dx is already there. So 4 into 4 is 16. At x4 the gradient is 16. Now this is a cubic function. Y is equals to x cube minus 2x plus 1. Derivative of which would be power comes down and multiplies with it. So 3x and reduce 1 from the power. Minus 2 power, there is no power written on x, so that means it is 1. So 1 into 2 is minus 2 and 1 minus 1 is 0. Anything raised to power 0 is 1. So basically this is 2 into 1 and derivation of constant is always 0. So this is your differential, 3x square minus 2. Now whatever the second part of the question would be, find the gradient or whatsoever, you will just substitute the value of x in the given point. So this was about the gradient. There are few more things, turning point and then the nature. We'll see step by step. Gradients, still gradients. So 12.2, finding the derivatives. This is how you find the derivative, by taking the power down, multiplying with constant, reducing 1 from the power. Find the function f of x is equals to x square. Use the definition of the derivative to show that f dash 2. Now what is f dash? Basically when we have y, we go for dy by dx. In case when you'll have x, you will be having f dash as the derivative. And in case of double derivative, this is d square y over dx square, and the double derivative would be f double dash x. So this is your double derivative. And in your first question it says that f dash 2 is equals to 4. So for the given question, given case, it is f of x is equals to x square. We need to have f dash, so we go for derivative. Derivative is bring the power down, multiply it with the constant and reduce 1 from the power. So this is 2x. When it is 2x, find f dash when x is 2. So when we substitute 2 in the expression, you get 4. So it is shown f dash of minus 3. F dash was already f dash of x was 2x. So f dash of minus 3 would be 2 into minus 3, and your result is minus 6, and so on. Any confusion till now? Part B is clear? Okay, part A was when f dash is 2. So this was your f of x. You took the derivative. Derivative is f dash x is equals to 2x. F dash means derivative. I'll write that again. Yeah. Limit. It approaches to. We'll come to that. Okay, I'll explain first. Suppose we have value y is equals to x square, and this is the sketch. If I say x is equal to 4, so when x is equals to 4, we all know that y is equals to 16. And when I say y is equals to x square and I say x actually approaches to 4, it approaches to 4, it is not 4, it approaches to 4 would mean 3.9999 infinite times. It approaches to 4. We will always substitute the same value, but we will say that y approaches to 16. For example, in this same graph, we know that when x is 1, y is 1. When x is 2, y is 4. When x is 3, y is 9. So when the value of x is increasing, and we know when it will reach 4, at that time the value of y would be 16. But what if I say x is approaching to 4? So at that point I will say that y is approaching to 16. So this is LIM, limit. It approaches to that point. For example, if we have a question, f of x is equals to 3 over 2 plus x. Now when the values are discrete, f of 1, that is 2 over 3 over 2 plus 1, that is 3 by 3 is equals to 1. So clearly f of 1 is 1. F of 2 is 3 over 2 plus, we substitute 2 in place of x, is 3 by 4. That is clearly 0.75. F of 1 is 1, f of 2 is 0.75. We can say f of 1 is equals to 1. We can say f of 2 is equals to 0.75 or 3 by 4. But what if I say x approaches to 10? So f of 10 is equals to 3 over 2 plus 10 is 3 over 12 is 1 by 4. It is not exactly 1 by 4. Now we will say f of 10 is approaching 1 by 4. If you would have noticed one thing, value of x was 1, then value of x increased to 2. When the value of x is increasing, the answer is decreasing. Value of x became 10, the answer decreased even further, 0.25, because x is in denominator. So what happens if x becomes very large? This was 3 over 2 plus x. If x becomes very large, the denominator is becoming large, so the answer would reduce to a very small value. So we say that x approaches to infinity, when x approaches to infinity, you know that x cannot approach infinity. Infinity is something unapproachable, so we call it infinity. So we know that it would be infinite over 2 plus infinite, and we know infinite plus anything is infinite. So 3 divided by a very large number would be 0, or you say it approaches to 0. Getting it? Now see, it says that f dash x. Okay, let's do this first. F of, where is this pen? F of x is equals to x square, and f dash means a single derivative. Single derivative is 2x. Now in this question it says that h approaches to 0. Show that f dash x is equals to limit of h of 2x. So that was f dash of x is equals to limit 2x plus h, and h approaches to 0. Now in this case basically h is the constant, and in derivative we do not have anything like that, so it is approaching to 0. Hence deduce the value of f dash x is equals to 2x. Deduce that is already the case. We just did it. F dash x is equals to 2x. Now it says the point with the coordinates -1, 4 lies on the curve. Equation is this. The point B also lies on the curve and has the coordinate this. Show that the gradient of the line segment AB is given by this thing. So it is x cube minus 5x. It says that y is equals to x cube minus 5x, one thing. The other thing is a is -1 comma 4, b is the x coordinate of b is -1 plus h, and y coordinate is basically unknown. So first I'll find the y coordinate of b. So y is equals to x cube minus 5x. When you substitute the x coordinate, -1 plus h cube minus 5 into h. So this is the y coordinate, and we'll simplify -1 plus h into -1 plus h whole square minus 5h. Are you getting the point? We already have a. I'm finding y coordinate of b. This y coordinate is unknown by substituting the x part in x. So -1 plus h square of this is a square minus 2ab plus b square minus 5h. Then multiply these two brackets. -1 plus 2h minus h square, h with this, h minus 2, yes. Now this x coordinate, I've substituted this x coordinate in this equation in both the places at place of x. And then I wrote this cube as one bracket aside and one as square. This is power 1. 1 into squared is 2 plus 1, 3. Because I don't know the expansion of cube. I haven't memorized it. You can do it directly. Oh, thank you so much. This is -1 plus h. Thank you so much. -1 plus h. Thank you. And this became -1 into -1 is plus 5 and minus h. Okay, now rearranging x cube first. And we have x squares. How many x squares do we have? 2x square and x square. So this is -3x square and simple h, 2h, 3h minus 5. 3 minus 5 is minus 2h. So we're done with x squares, we're done with simple h, we're done with cube, and 5 minus 1 is 4. So this is the y coordinate. Now gradient is y2 minus y1 over x2 minus x1. So taking b as the second point and a as the first point, so y2 a cube minus 3h square minus 2h plus 4 minus y1 over x2 minus x1, and then simplifying. So h cube minus 3h square minus 2h, we get rid of this, divided by minus 1 is plus 1 divided by h. So everything is divided with h. This is h square minus 3h minus 2, and let's just tally it. This was h square minus 3h minus 2 shown. This is the first part. Second part says deduce the gradient of the curve at point A. Gradient of curve at point A. So curve was y is equals to x cube minus 5x. Derivative would be dy by dx is equals to 3x square minus 5 at point A. So the x coordinate at point A is minus 1. 3 into minus 1 squared minus 5 is 3 minus 5 equals minus 2. Clear? Okay, prove from the principles, first principles, that the derivative of 6x is 6. So the principles are basically the rules. So let us write y is equals to 6x. So dy by dx is equals to, you multiply it with the power and subtract 1 from the previous power. So this is 6 x raised to power 0, which is 6. I think there must be something more as well. Why is he asking for proofs? Let me have a quick look if I skipped something, because in GCE there are no proofs. Finding the derivatives, estimates, gradients. There's one more thing which we can do, is the equation was y is equals to 6x, and we have to prove that the gradient is 6. So y is equals to 6x. So let me consider in some two values. Let's say x is 1 and x is 2. So when x is 1, y is 12. When y is 6, and when x is 2, y is 12. So gradient is equals to y2 minus y1 over x2 minus x1 is again 6. That is a straight line. Differentiating x raised to power n, we just covered it indirectly. Find the derivatives f dash of this. So 6x is 6x, 5x raised to power 6 is 6x5. This is 1 by 2 x raised to power minus 1 by 2. We subtract 1 from the power. This is minus 2 x raised to power minus 3. When you multiply both of these, this becomes x raised to power 5, and then you derivate it, this becomes 5x4. This is x over 5, so this is equal to 1 over x power 4. We can write this as x raised to power minus 4. Then the derivative would be d over dx would be minus 4x minus 5. You can leave as it is, or you can rearrange and write x raised to power positive 5. Getting it? Who will tell me the gradient of 7x cube? Yes, differentiate. 21x square, right? Multiplying 1 by 2 with minus 4 is minus 2x raised to the power minus 1 by 2. Multiply the power minus 6, then subtract 1 from the power is minus 3. X goes with this, 6 is left, 3 and 8 has nothing to do, constant never disturbs you, so 6 into 8 by 3 and reduce 1 from the power. Now this is just simplification. 2 8 times is 16 x 5. Now there are two things with the square root. What you can do is this was square root 36x cube. So square root 36x cube, let me write y here. So we can write that this is square root of 36 into x raised to power 3 by 2. Square root of 36 is 6, x raised to power 3 by 2. Now you can differentiate it. So dy by dx would be power multiplied with 6. We take away 1 and this is your differential. So 2 1 times, 2 3 times, 3 3 times is 9. X raised to power 3 by 2 minus 1 is 1 by 2. There was one direct way of differentiating the square roots. For example, you have 2x plus 3. This is actually 2x plus 3 whole raised to the power 1 by 2. Now when you have power whole raised to the power something, the general form is y is equals to u raised to power n. First we did x raised to power n. Now this is u raised to power n. U is some function. So dy by dx is equals to, bring the power down, subtract 1 from the power, and next step is multiply with the differential of u. Now compare this with the given value. Y is equals to something raised to power. This 2x plus 3 is actually u. So dy by dx would be, bring this power here, 2x plus 3, subtract 1 from the power and multiply with the differential of u. So differential of u, 2x plus 3, the differential is 2. So your final, at the start this is the power right here. Now the power always comes down with the constant. Yes. And then for the derivative, we are bringing this power with the constant. The constant was 1. So 1 into 1 by 2, then when you subtracted 1 from the power, this became negative 1 by 2. I'll solve few more questions, you'll get this clarity. If we have y is equals to square root of 3x4 plus 7. So y is equals to 3x4 plus 7 power 1 by 2. First thing. Now dy by dx. This was the simplified form. First part is bring the power down. So this is the power, multiplied the power down. Bracket stays as it is. 3x raised to power 4 plus 7. And when you subtract 1 from the power, this is 1 by 2. Now next step is differentiate this bracket, which would become 12x. So multiply it with 12x. 4 3 times is 12x cube. This is your power. Further simplification would consider bringing this negative power down to make it positive, that is 3x4 plus 7 raised to the power 1 by 2, and multiplying this 12 with this 1. This is 12x cube. Furthermore, 2 1 times, 2 6 times, So 6x cube over square root of 3x4 plus 7. If you see this part right here, 3x4 plus 7 is regenerated in the denominator. If you notice, this part 2x plus 3 under root is actually regenerated in this denominator. We can write this denominator as 1 over square root 2x plus 3. If you notice this, the main question is actually regenerated. So the direct form, how you can directly solve the square root questions is y is equals to, let's say we have square root of 6x square plus 2x. So whatever the question is, dy by dx, you always write 1 over 2 and rewrite this 6x square plus 2x. One thing, and then you multiply it with the differentiation of this function inside the square root, which is 12x plus 2. This is how you can directly solve the differential involving square root. And further, definitely there is a chance of simplification. We can take out 2 common in the numerator. This is 6x plus 1 over 2 square root 6x square plus 2x, and you get rid of this. You're left with 6x plus 1 over square root 6x square plus 2x. There's only one difference between differential and the basic concept of this chapter. You may have different type of equations to differentiate. So you should know how to differentiate a simple equation. Let me write them so you can make a good comparison. For example, y is equals to x cube, first type. Y is equals to 2x plus 3 raised to power 7, second. Y is equals to 2x cube plus 3 squared into 3x minus 4 raised to power 3. So these are different types. You should know how to solve dy by dx, how to solve dy by dx, how to solve for dy by dx, this thing. Other than that, every concept is same. Derivative gives you the rate, derivative gives you the gradient. Examiner would ask, find the gradient when x is 7, find the gradient when x is minus 1. So first part, the differential is dy by dx is equals to 3x square. For second part, the differential is dy by dx is equals to, bring the power down, 2x plus 3 whole raised to power 6. Then differentiate this bracket and multiply with it, that is 2 in this case. Simplification is always required. 7 2 times is 14, 2x plus 3 power 6. Now what this is basically the product rule. Let's go into product rule first, and then we have further types, one of which is quotient rule. What the product rule is, when you have two brackets being multiplied with each other, u dot v, dot means multiplication. So dy by dx would be first function into differentiation of second, this dash represents differentiation, plus second function into differentiation of first. So the question was, y is equals to 3x plus 3. Let's say we have this function. First I'm making it simple, then we'll add powers to it. 2x minus 5. Yes, Mohammed? Yes, sure. So 3x plus 3 into 2x minus 5. First function dy by dx is first function into differentiation of second. So second, the differentiation is 2, plus second function into the differentiation of first. Differentiation of first is 3. So 2 3 times is 6x plus 6. 3 2 times is 6x minus 15. So 12x minus 9 is the differential of this main equation. Let me reopen this. Okay, roots are actually simple. You can do them step by step or directly, makes no difference. For example, y is equals to square root 3x cube plus 4. First I will do it step by step, then directly. Y is equals to 3x cube plus 4 raised to the power 1 by 2, or let's do it parallel and compare them. Y is equals to 3x cube plus 4 dy by dx is equals to whatever, whenever you face this square root, write this 1 over 2. Done. When we write this 1 over 2, second step, copy the main question in the denominator. First step 1 over 2, second step copy the main question, third step differentiate this part. This would be 9x square into 9x square. This is your final step, final answer. Now let's compare. Dy by dx, we know that we have to bring this power down. So when I bring it here, this becomes 1 by 2 into 3x cube plus 4 raised to power minus 1 by 2. Then we differentiate this bracket and multiply. That is 9x plus 9x square plus 0, 9x square. Now you simplify. Because of this negative power, it comes down in the denominator and becomes positive. So this is 3x cube plus 4, and we have the same answer. I'll write the general formula as well. If you have y is equals to square root of u, so dy by dx would be 1 over 2 square root u, 1 over 2 written, main question copied, into d over dx of u into the differentiation of whatsoever is under this square root. Y is equals to square root 7x square plus 3. So dy by dx, first step 1 over 2, second step copy the main question, third step differentiate what is inside, so 14x, and next part is simplification. In this case this number is even, so we can cancel it with 2. 7x over square root 7x square plus 3. More questions. Y is equals to 7x cube plus, let me do it with odd numbers so we don't have to cancel them, 5x 7 whole square root. So first step, dy by dx is equals to 1 over 2. Second step, copy the main question, 7x cube plus 5x 7. Third step, differentiate what is inside the square root, and that is 7 3 times 21x square plus 7 5 times 35x 6. This is your answer. Either you go step by step or you solve it directly for square roots. This is always your answer. If there are doubts, we can clear them. Other than that, it is practice. To be comfortable, it is practice. You see these questions right here, x bar 7, x bar 8, x bar minus 4. You should know how to differentiate them. Now these are square roots, and look at this question, 4x6 over 2x cube. These are actually simple ones because first you can simplify them. So 2 1 times 2 2 times, left with 2, 3x gone with 3x in numerator, so we're left with 2x cube. Now we can differentiate this 2x cube. We first simplified it, then we did this when we won't be able to simplify, then these are the rules how you do them. Differentiating equations. Differentiating equations. Okay. Find the gradient of the curve with the equation. Question number 2. Equation is given, point is given, and we have to find the gradient. Exercise 12D. Question 2, A part. Y is equals to 3x square. So dy by dx would be 6x at 2, 12. So we have to find the gradient, we only need x. So the gradient is 12. Question number 3. Find the y coordinate and the value of gradient at point P with x coordinate 1 on the curve when y is equals to this. So equation is, question 3, equation is y is equals to 3 plus 2x minus x square. Find the y coordinate first thing and the value of gradient at point P with x coordinate 1. X coordinate is 1. So when x coordinate is 1, we substitute 1 and we get 3 plus 2 minus 1, 4. So when x is 1, y is 4. First part done. Second part is the gradient at point P when x is 1, the gradient. So dy by dx for this equation is 3 is constant, that's gone, plus 2 minus 2x, and we know the value of x was 1, so the gradient at that point is 0 when x is 1. That's given in the question. This right here, x is given, x coordinate 1. Question number 4 says find the coordinates of the point on the curve with the equation this, where the gradient is 3. Now gradient is given and we need to find the coordinates. The equation is y is equals to x square plus 5x minus 4 and gradient is equals to 3. Points are unknown, gradient is 3. So dy by dx is equals to 2x plus 5. Gradient is given, substitute. 3 is equals to 2x plus 5. 3 minus 5 is equals to 2x. Minus 2 is equals to 2x. X is equals to minus 1. So we know that when gradient is 3, x is minus 1. And when x is minus 1, y is equals to minus 1 squared plus 5 into minus 1 minus 4. So 1 square is 1 minus 5 minus 4 minus 8. So minus 1 comma minus 8. Point coordinates are minus 1 minus 8 on this given equation when the gradient is 3. Getting it? Equations may change their shape, may change their type, the nature of the topic stays the same. Now this thing right here tells you differentiating functions with 2 or more terms. 2 or more terms basically are simple. 4x cube plus 2x, these are 2 terms. In B part these are 3 terms. In C part again it is 2 terms. So whatsoever it is, you should know how to differentiate 4x cube. You should know how to differentiate x raised to power 1 by 2. How to differentiate x raised to power 1 by 2. Constant is nothing. It is not a problem. Now differentiate these. In this case, it is quite possible to do it in 2 ways. Example B, let me copy this first. X cube into 3x plus 1. We just practiced u dot v. I'll write that again. U dot v was dy by dx is equals to first function into differentiation of second plus second function into differentiation of first. Okay, this is one way. The other is directly. In this case, it is quite possible to do it directly. I'll compare it with both. Let me say this is x cube is the first function and 3x plus 1 is the second function. So dy by dx would be first function into differentiation of second plus second function into differentiation of first, right? Do we have any issue till now? Simplifying, this becomes 3x cube plus you multiply this 3 with both of them. 3 times 9x cube plus 3x square. 9 plus 3 12x cube plus 3x square. Now see what we can do here. First multiply this inside. This becomes x3 x4 plus x cube. So when you differentiate this becomes 4 3 times is 12x cube plus 3 with 1 and x square. So 12x cube plus x square, 12x cube plus x square. In this case, it was possible to multiply these two brackets and get 1. 2 brackets to get 1. But there will be cases where we will use u dot v. For example, 2x plus 3 squared into 2x minus 3 cube. So in this case, first function, second function would be very easy. Or y is equals to square root of 2x plus 3 into x cube. Now this is not simple like this one to multiply it inside the bracket and get our values, because x cube is now multiplied with 2x plus 3 raised to power 1 by 2. If it would have been square, we can still expand it. But in this case, u dot v would be very helpful. So these are the shapes. You should know how you can differentiate them. 2x plus 3 could be written as 2x over x plus 3 over x, and finally simplified to 2 plus 3 raised to power 3 into x raised to power minus 1. Now I am differentiating this. First is constant, so we get rid of that. Second part is minus 3x minus 2, and your final answer is minus 3 over x square. This, getting it? So simple request, as we always make, practice. Then in this part, when we will start gradients, tangents and normals, we won't be going through how to differentiate, but we'll be going through the applications, how to do them. Tangent is simple gradient, normal is perpendicular, which you used to do in O levels. m1 into m2 equals minus 1. So when you differentiate, what we just did, every differentiation was basically the tangent. So every differentiation is tangent. The normal would be m1 into m2 equals minus 1, and depending on the nature of question, the unknowns, we will be solving them.